Hello, welcome to this new training session regarding a new add-on on the Moose framework, and this is regarding set classes. And in this session I'm going to explain you what set classes are, and I'm going to explain you and demonstrate you how the set group class is working. Set classes as a new add-on are basically collections of objects that are dynamically growing and shrinking during mission execution, because during mission executions objects will get spawned or may get destroyed, right? And these set classes are following those objects. The base class within the Moose framework for set object is set base. And set base implements the core functionality to manage sets. Derived classes from set base currently within the framework is set group and set unit. In this session we're going to focus on set group in order to make the video short, condensed and understandable and not too long. Alright, so set group, as I explained, will manage the different group objects that are being spawned within the mission. And do remember from the previous session that the group objects that are being spawned are being monitored by the database object. So there will be group A, group B, group X will be wrapper classes will be spawned as well within the database object, and the set group collection or class is monitoring the database and is selecting those group wrapper classes that are complying with specified filter criteria within the set group. And filter criteria can be specified around a coalition, a country, a category and a prefix name, because these are the properties that are belonging to each separate group. You can have groups from coalition red or blue, you can have groups from country Belgium, Norway, Sweden, and you can have different categories of groups, ships, planes, and groups have different names, so you can filter on the name as well. So how do you declare a set group class collection? Well, very simple. In this example I'm declaring a heli group set object that is an instance from the set group class, and new is a constructor. It takes no parameters for the moment. Filter coalitions, filter countries, filter categories and filter prefixes are the filter methods that you can use to filter on coalitions, countries, categories or prefixes. Filter start is a function, is a method that you need to call at the end once all of the filter criteria have been specified for the group, because filter start will actually start filtering the database and taking those group objects that are applying according to the filters set. So it's important to remember that a set first needs to be declared in the beginning of each mission, because as you know, sets are dynamically growing and shrinking, they will also be initialized at the beginning, and they will scan the complete database of your mission looking for groups that are compliant with the filter criteria, and the set will be built. So it's best to do this initialization of set group classes at the beginning of your mission. In the demo it will become more clear where that can be done. Let's talk a bit about the filter criteria. How do you specify filters for coalitions? Well, as I said, the function filter coalitions takes a parameter, a table, coalitions. And this is a table of strings, so you can specify here actually two values, blue or red. Yeah? These strings need to match, so the syntax of the strings need to be correct. When you want to filter on specific categories of groups, then you have 5 options here. You can filter on a plane, helicopter, ground units, ships and structures. Countries is a bit more complicated because countries are dynamically added by Eagle Dynamics in their product. So instead of me hard coding within the framework each country, I am actually following the countries that are being specified by Eagle Dynamics. And these are not properly documented, or at least I have not found a complete comprehensive list of all the countries, but there is a file dbcountries.lua which you can find in the DCS World Scripts database directory of your DCS World installation folder. If you look into this file, you will find all of the countries that are currently alive within the simulator. So I've just went through the file and I've listed for you all the countries within this presentation. Do mind that the country names need to be capital letters and a space is expressed with an underscore. Very funny is, for example, the underscore Netherlands, while we in Belgium would say Netherlands, not the Netherlands, but anyway, fine. Another one that you need to keep in mind is North Korea with an underscore, Saudi Arabia with an underscore, South Korea with an underscore. We also got countries insurgents and aggressors, which probably will be future parties that will be added, not specific to a certain country. Okay. Filter prefixes is a very handy thing. During your mission design, you want to have certain groups with a certain name. Yeah. So if you choose the names carefully, you can build sets where you can then express a filter using the name prefix, which is the beginning of the name matching a certain string. So, for example, if you want to collect all of the groups that are beginning with the word Sam, then you say filter prefixes between brackets Sam, and it would collect Sam A, Sam SA13, and so on and so on. The combination of these filter criteria allow you then to build comprehensive sets of groups, and it's really very handy. Why is it handy? Because these sets can be iterated. So what does iteration mean? Iteration means that you are looping the set. So for each group belonging to the set, I am calling a function. What is an iterator? An iterator is basically that function that allows you to iterate the set. So you'll find different iterator functions within set group, and they start with the word for each. For example, in this one I'm having for each group an iterator that is calling the function for each group belonging to the set. It's a bit of a strange declaration, but basically what this code fragment is doing, it calls the function heligroup and it provides the object a group object that's in capital, so a real group class instance within using the name heligroup, and then you can use the heligroup group instance to do certain activities. Why is an iterator better than normal loops? Because normally during programming you could also do a for do loop. The problem is that when you have sets that are larger, for example like 500 objects in your set, and you're gonna do a for do loop every second, this will slow down your mission significantly and you will get stuttering behavior, meaning your mission execution will stutter. You will find when you fly your helicopter or your plane that every second there is kind of a halt in the execution of the mission. It doesn't run smooth anymore. So the iterator allows you to actually iterate this set, and what it will do, it will create a new thread. So what is a thread? You got your main mission execution thread, and when you do for each group, this function will actually start looping each group in steps, in intervals, which you can specify, but I'll add a parameter for that later. I'll document that in a later session. So right now the parameter is every 10 groups the function will be called, but once 10 groups were finished here in this example, the processing will be handed over back to the main processing loop and other functionalities can be executed. And once that is done, then for each group will continue from where it left off. So if you got 22 groups, you'll find that the setGroup thread, the for each group function, will actually execute within 3 steps the complete iteration. This may take a little bit longer, but it really prevents from your mission stopping from performing well. So this is not the only iterator that's available. There are others, and probably within the future more iterators will be added as more ideas and demands will come. So in this example here, the setGroup object also contains iterators to iterate the group and evaluate whether the group is within a certain zone object. In this example, if the group is completely within the zone object, then this function will be called. Another iterator is partly in a zone. So if a group in the set is partly within the zone specified by zone object, then the heli_group function will be called. Or not in the zone. Same thing. If the group from the set is not within the zone specified by a zone object, then this function will be called. So as you can see, setGroup has a lot of potential, and for the moment I'm going to stop with this presentation because otherwise it makes too long. But you can consult the documentation on the Moose GitHub pages, or you can watch this video on the YouTube channels on YouTube. You can find this presentation, which most of the time I forgot to explain this, but in the Moose pack you can find these presentations in the Moose training directory, and here are the presentations, and the presentation that I'm currently presenting is reflected here. Part 1, setGroup. Part 2 probably will be setUnit, and if I'm adding other kind of sets types, then there will be a part 3, part 4, or even when I'm adding more useful functions that need to be explained within a video, I'll add more parts. Okay. There are training missions as well, and for this I'm going now to the demonstration. So in this video there is a Moose test setGroup training video that you can download on GitHub, which you can find here if it wants it to show. No, hang on. Yeah, here it is. So where is it? setGroup, here you go, and it is this Lua file here that you can see an example on how the setGroup here is being used, and I'm going to explain you this mission right now, how this is working. Okay, so let's go back to the editor now. Voila. So here, as a demonstration of setGroup, I am declaring a blue planes group. So I'm filtering the coalitions blue and plain. I'm North Korea, Russia group, that should be, yeah, doesn't matter, so I wrote Russia here. A SAM group set, so the set will select all those units that start with SAM. And what I'm then going to do within the mission, I'm going to spawn a USA plane, a USA vehicle, a USA ship, a Russia vehicle, a Russia ship, and I'm also going in a loop to declare or to spawn 30 M2A2 tank vehicles and 30 SAM attack vehicles, yeah, within a circle. Let me show you this a bit. So here, what I'm going to do is, you see this will be spawn. It's currently late activated. This is already within the mission, not late activated, because as I said, when you declare a set group, it will scan your mission for all the available groups that are currently alive, and those that are dynamically spawned will be added dynamically into the set. So when I'm going back now, and this is going to be the demonstration here that I will show you, is that in the mission script, let me see here. What am I going to show you? Yes, that I'm going to use now the iterator for each group, and I'm going to go over the set blue planes group. So what I'm going to do is I'm going to smoke every unit that's within the group in a blue smoke. Okay, now let me show you how that is working. So what you will see is this plane is not late activated, is already available and is blue. This plane is a plane that is late activated, is blue, but will be spawned dynamically, and you'll see blue smoke coming out of these planes. So here I am right now on the airbase. I'm having two drones alive, which are currently taxiing from the airbase. They're blue, and this iterator function is working very nicely. So let me repeat. This demonstration was this small lines of code that were being executed, and actually this is even a comment. So with some really condensed code, you can really iterate a set and call a function for each group within the set and do some actions. Okay, let's go to the next one. The North Korea group, which I named wrong. It should actually be North Russia or Russia group. Yeah. Basically, I'm going to collect each Russian, what is it here? Yeah, each unit from Russia, and I'm gonna smoke it red, right? So I got two vehicles within the mission here that were set that are from Russia. Now they're located near the blue ones. I've put weapon hold, of course, yeah? So again, to repeat, there is one of these units that are already alive because late activation is not switched on, so they will be alive when the mission starts. I'm spawning a new one here, and this new one will be added dynamically. So I will see two red smoke because I will have two red two Russian vehicles within the running mission. So here we are in the mission. It's running for the moment. You see the two red Russian vehicles being spawned, and when I view them, then they have a red smoke. Okay. The next demonstration is a bit more interesting. I'm going to iterate the set SAM group, so the set of groups composed by SAMs, which is this one. So I filtered on the prefix SAM. So each unit starting with the name SAM will receive an orange smoke. Let me walk you to the mission where these are located. They are located here. I will spawn in this zone 30 SAMs, so 30 spawned as SAM attack vehicle, and I will spawn 30 A2 M2A2 attack vehicles. Here they are, a mix of vehicles spawned within the zone. Let me view one. Now, as you can see, by iterating the set, only the SAM vehicles are smoking orange. The tanks are not smoking. Okay. Do remember that I also talked about, let me go quickly back through the demonstration or the presentation, about iterators that scan zones. We got an iterator for each group completely in zone, partly in zone, and not in zone. So within the demonstration, I've added this code here, which is basically defining polygon zones. For that, you need to refer to the zone training video if you want to know more about that, if you might have missed it. So I'm having polygon zones being defined by groups. So I scan the groups, then I create the polygon objects using the group waypoint parameters. I'm smoking those zones white, so the parameters of the zones will be colored white. And within the mission, these zones are being defined here. So this is the first zone where the complete test will be done. This is the partly zone test, and this will be the not in zone test. Right? Then I'm going to spawn groups consisting out of 2 vehicles, an infantry and Bradley here, an infantry and again a Bradley, and I'm going to spawn them within the circle here. So you'll find 60 vehicles being located within the circle, and in this test spawn zone completely, I'm going to smoke only those groups that are completely within this triangle here. In this test, I'm going to smoke only those groups which are partly within this triangle. So it could be that one vehicle is here and the other one is there, and it will still smoke. Within this test here, I'm going to smoke only those vehicles that are outside of the triangle, right? So before I do the demo, I want to show you how the code looks like. So these coding is really done very simple. I'm just calling this function here, but I'm giving here the zone object as a first parameter to this function, and here and here. So I'm doing the completely in zone test here, I'm doing the partly in zone test there, and I'm doing the not in zone test here. Okay, so I'm now in the running mission. Within the running mission, you'll see about a lot of vehicles being spawned within the circle. This will be the complete in zone test that will be executed here. So let me select the vehicle, let me view it, and as I said, the zone parameters are highlighted with a white smoke, and you see the blue, only those blue groups that are completely within the zone are being highlighted. You will see even units within this zone that are not being smoked blue because their other counterpart is outside of the zone, so they're not completely within the zone. Let's go to the partly in zone then. How does this look like? Partly in zone really looks like this. So now I am smoking those groups which are partly within this triangle. Yeah, some units which are completely outside of the zone are not being smoked at all. And here, in this test here, the last one, the not in zone, I'm only smoking those vehicles which are... So I hope you found this demonstration interesting, and especially the set group functionality. I'll work next week on, or maybe tomorrow or the day after, on the set unit training video as well, which is very similar to the set group, so I think the training video will be shorter. So you can, if you have any question or any idea to add functionality on the Moose framework regarding these set classes. You can reach me on Skype, flightcontrol_Skype, or join the slack.com development community at the indicated web address. So I hope you found this interesting, and see you next time. Bye bye.